Okay, so let's look at the first of a couple of a series of examples we'll do on osmotic pressure. And osmotic pressure relates to this idea of how much pressure does a solute need to exert on a liquid or a solvent to stop the flow of ions from one region to another region through a semi-permeable membrane. Or put differently, what is sort of the pressure exerted by dissolving a solute in a solvent, right? So, because I mean, when you dissolve something in a solvent, there's going to be some um, change in the volume. The volume might decrease a little bit. So it's like exerting a bit of a pressure on it. I mean, you can think of it in different ways or manners, but that's essentially what we'll be looking at. Well, not necessarily specifically that, but so that's in the series that we'll be looking at. So in this example, we're told at 25 degrees Celsius, the osmotic pressure of blood is 7.7 atmosphere. Determine the mass of glucose required to make 1.5 liter of a solution that is isotonic with blood. Now, isotonic, so that's the important word. So we're given some information about blood, and then we're told we need to determine some mass of glucose required to make a 1.5 liter of a solution isotonic with it. So the important thing is we need to know what the word isotonic means. And isotonic means same osmotic pressure. So maybe write down for yourself isotonic is the same osmotic pressure. Right. So if we need to know what is the same osmotic pressure, or what mass of glucose needs to have the same osmotic pressure, we're in principle given this temperature, the pressure, and the volume of what the glucose solution needs to have, the properties that this glucose solution needs to have. And if we look at the whole what do you call it, osmotic pressure equation, it is pressure is equal to CRT, right? So osmotic pressure is equal to CRT. And C, I mean, of course, is concentration. So in some form, it is the number of moles divided by the volume, RT. And if we get the number of moles, we can always get the mass of the substance. So we have the volume, we have the temperature, and we have the osmotic pressure. So we can just quickly solve this for the number of mole, and specifically in this case, it's the number of mole of glucose. So number of mole of glucose, volume, RT, and we just substitute in the values. This is 7.70 atmosphere on 1.5 liter. We need to choose the correct R. So the R value we want to choose needs to contain atmosphere and liter. So we can use the one that is 0.0820, and then there's one that is a 5 something, but it's 6 whatever liter per liter atmosphere per Kelvin per mole, and this is at 298.15 Kelvin. Will give you a value of 2.472 mole, and then therefore the mass of glucose, course equal to the number of mole of glucose multiplied by the molar mass of glucose. And the molar mass of glucose you can go and calculate. Go and have fun with that. C6H12O6. And you should get a value of 85.0 gram. I mean, so you can see that to exert that amount of pressure in your blood, you need to ingest quite a lot of sugar, or the concentration of sugar has to be quite high in your blood, so you should be safe. Anyway, right. It's just a basic example. It's just a basic use of the equation, just a reminder of what the pressure is, and actually a reminder that concentration is mole per volume. So if we're searching for a mass, then you're always looking for a way to relate mole to it. Okay, thank you for watching, and I'll see you in the next video.